Clark here at Killer Fun, back with another Daily Killer Sudoku solve video. This puzzle is number 1765 at dailykillersudoku.com. This was one that I had solved previously, but when looking at some Daily Killer Sudoku statistics, I decided to revisit it. The statistics I was looking at was the top 10 least solved puzzles. I'm looking at a ratio of the actual solves versus the number of attempts. Percent solved as a measure of the demonstrated difficulty. Here is the top 10 table. The percent solved value for this puzzle is only 11%. At number 5 in a list with mostly 9s and 10s, puzzle 1765 is the one kid playing its own game. Is puzzle 1765 a difficulty 10 wolf in difficulty 2 sheep's clothing? It has the second longest average solve time. Puzzle 1765 was also in my Daily Killer Sudoku My Puzzles list with an embarrassingly long solve time. So I had to make a solve video to find out about its true difficulty and to record a redeeming time. Let's look at the puzzle and see what we can learn before we start the solve. This is a difficulty 2 greater than Killer Sudoku puzzle with an average solve time of 52 minutes. The board is symmetric, top to bottom, but the greater than missing sums make mirrored opportunities difficult to come by. If you would like to follow along or give it a try first, there is a link to this much abandoned puzzle in the description. Let's get solving. All right, let's see what we can do with puzzle 1765. Starting off in box 8, row 9, and a 2-cell 3 cage can only have 1-2 pair. Now, there are very few of these traditional starting spots. There could be a 1 in this 3-cell 8 cage. We're going to leave that out for now. It's not going to help us in our solve. We could put a 9 here in this 3-cell 22 cage, but again, it's not really going to help us out. So the real entry and what I'm going to call crux number 1 is getting started with this puzzle. There's very little to do. I mean, there is, you could sort of call this a rule of 45. There's a 2 in, 1 out rule of 45 here. We may use that later in the puzzle. There's not a lot going on. Because of the greater than nature of the puzzle, it's difficult to get a toehold on this. This triple here is a 12 sum, but really there's not a lot going, except for this rule of 45 opportunity here with a 4-cell Outie. And normally I would say, okay, a 4-cell Outie, what good is that? Well, it turns out it's really great because if you look at the combined sum of the highlighted cages here, it's 75. That's 30 more than 45. So if you put 30 in our calculator with a 4 as the number of cells, 6, 7, 8, 9 is the only possible combination. So I don't really deal with the 4-cell Outies much, but this is very helpful for us. So let's put the 6, 7, 8, 9 into these 4 cells here. So this 30 sum will get us started in the puzzle. Now if we start working down here in box 7, what would we put in these 2 cells of this 3-cell 10 cage? If we look at the possible combinations up here in the upper right, the 1, 4, 5 combination and the 2, 3, 5 combinations are not possible because there's not a 5 or a 1, 4, 2, 3 either. And if we look up here in the combinations, there's not an 8, 9, so we can remove the 8, 9 here. The only candidates for this 10 cage in column 2 are 6, 7. Now, this 3 cage that has a 1, 2 helps us eliminate one of those, and that is this 1, 2, 7. This cell here has to be the 7, so there would need to be a 1, 2 there. So we can eliminate the 1, 2, 7 as a possible combination, and the remaining combination is 1, 3, 6. Again, this 2-cell 3 cage helps us out in that there's already a 1 in this row. And if we need to place a 1, 3 pair here, that sets a 3 in row 9, column 1, and a 1 in row 8, column 1, and makes this a 6. So in the remaining 3 cells of our 30 sum, we can remove a 6. So let's move on to this 15 cage. We see that the combinations for a 2-cell 15 cage are 6, 9, and 7, 8. Because of this 6 here, the 6, 9 combination is eliminated, and it can only be a 7, 8. So we have a 7, 8 here, and we can remove the 9 from this cell. That forces the 9 into these two. Let's move up here to box 1, and let's look at this 10 cage. What are the possible combinations here? Well, the only one that's not represented is this 4, 6. And the partners of 7, 8, 9 are 1, 2, 3. And down here in column 1, we have a 1, 3 pair that places a 2 here. That makes this an 8, which resolves this into an 8, 7 pair, which makes this one a 9. So here in box 1 in the 18 cage, this 3-cell 18 cage, what are the possible combinations here? Well, we've got to have a 9, so we can eliminate all but 4, and we have a 1, 2, and a 3. Now, if you think about this, this is truly a 9 sum. 9 plus 9 makes 18. So it's as if we were looking at a 2-cell 9 cage. And if we take a look at that in the calculator, we can see it, but just not as easily here. If we take a look at the calculator and do a 9 sum with 2 cells, you can see we have 1, 2, 3, 4, and then 5, 6, 7, 8. So if we have 3 of the low numbers, we know that there's only one possibility left. So we have a 1, 2, 3, and so 4, 5 is the only possible pair that would go into this 9 sum of the 18 cage. So this is a 4, 5 pair. Moving down the stack to box 4, let's look in this 22 cage. The only remaining candidates there are a 6, 7, and 9. Continuing down into box 7, let's fill in the remaining candidates 2, 4, 5, 9, with the 2 only in row 7, 8 of column 3. So we'll put the 2 here, and the rest get a 4, 5, and 9. And the 2 can only be up here in these 2 cells because of the 2 in this 3 cage in box 8. The next step in the puzzle is what I'm going to call crux number 2. We can use this greater than inequality clue to help us eliminate candidates in the 3-cell L cage that spans between boxes 7 and 8. This 3-cell cage must be less than 10 because of this greater than inequality sign. A 3-cell cage has a minimum value of 6, so the possible sums are 6, 7, 8, and 9. A 9 candidate has no place in this scenario, as the maximum sum is 9. So it can be removed. This 1 in box 7 sees all 3 of the cells in this 3-cell cage. Thus, there can be no 1 in this 3-cell cage. Looking at the calc tool with a 6-sum 3-cell cage, the 6 and 7 combinations both contain 1s. Because of this one, we know both of those are not possible. The 8-sum has 2 possible combinations, both containing a 1. Again, neither of these is a potential combination. And the final possible sum of 9 has 3 possible combinations, 2 of which contain a 1. They can be eliminated. So the only possible combination for this 3-cell cage is 2, 3, 4. That means we can remove the 5s and place a 3 here in row 8, column 4. Now we can do some cleanup here in box 7, row 9. We can remove the 4s from this pair. So we have a 2, 4 pair and a 5, 9 pair in box number 7. And this 5, 9 pair can be resolved by the 9 up here in the column looking into this pair. So this turns out to be a 5, 9 pair. Now staying in this bottom band, we can move right and make some progress here in row 7. And that starts by looking at this equals inequality clue. This is here in box 8. This is a 2-cell cage, but it must equal the sum of this cell. And we know the sum of this cell is 9. So this must also be a 9. Again, we see this scenario where for a 9 sum, we know there are 4 possible combinations. We already have the 3 lowest combinations can be removed. 1, 2, and 3 are already in this box number 8, with this 2-cell cage. So the only remaining combination is a 4, 5 pair. This 4, 5 pair helps us resolve this 2, 4 pair in box 7 to a 2, 4. Continuing in row 7, we have another 2-cell cage which is informed by a greater than inequality. This 2-cell cage must be less than 9, and there are a limited number of possible candidates. So let's plug in those candidates. The possible candidates are 1, 3, 6, and 9. Now, since this is a 9, and this cage here is less than a 9, we know this cannot contain a 9. And it cannot be a 3, 6, because that would also be 9. So what would it be? It could be a 1, 3 or a 1, 6. We can eliminate the 1, 3 combination because there is already in this box a 1 and a 3. So we can remove 1 and 3 from this cell, and that forces this to be a 1. If it was a 6, it couldn't be. It's not possible for that to be a 6. And if it was a 3, that would make a sum of 9. So this must be a 1. Let's try that again. There we go. So we can remove the 1, 6 from these two cells, leaving us with a 3-9 pair. And this 3-9 pair can be resolved because we cannot have a 9 in an 8-sum cage. A 3-cell 8 cage cannot contain a 9. Any number of cells that sum to 8 can't contain 9. So that's a 3, and this is a 9. Now, if we stay here in box 9, these two, we know the sum of these two 13 cages. They sum to 26. And if we know that an entire box sums to 45, so if we subtract 26 from 45, we get 19. So let's plug 19 into our calculator. And there are 5 cells here, so the number of cells is 5. And there are 5 different combinations that are possible, but only one that has a 1, 9, and a 3, and that's this top one. So the 2 cells here must contain this 2 and 4, and this 4 helps us resolve that into a 2-4 pair. Now, what would we do if we didn't have this great calculator tool? I'll put a link in the description to a post in my Killer Fun YouTube community page describing how this would be done if we were solving on paper or in another puzzle solving interface without a calculator tool. For me, I really appreciate being able to use this calculator tool. All right. Now, back here in the lower right, let's tackle this 8 cage. It's not going to be too difficult. There are only 2 possible combinations, 1, 2, 5, or 1, 3, 4. Since there's a 3 here, we know this must be a 1-4 pair, and this 4 helps us resolve that. So this is a 1-4 pair. The next step in the puzzle is to look up at box 3 and do some Sudoku with a bit of killer mixed in. Where in box 3 can we place a 2? We have a 2 here in row 3, and we have a 2 here in column 8. We also know that a 2-cell 13 cage cannot contain a 2. So the only place for a 2 is in this 8 cage. And the combination with a 2 for a 2-cell 8 cage is 2, 6. So this must be 2, 6. Now that helps us down here in box 9 with these two 13 cages. Because there is a 9, 4, that eliminates the 4-9 combination. It leaves 5, 8, and 6, 7. And prior to having a 6 here, we didn't know where the 5, 8 or the 6, 7 would go between these 2 cages. But now we do. With the 6 here, that forces this to be the 5, 8 pair, and this to be the 6, 7 pair. And we can resolve the 6, 7 pair to 7, 6. And with this 5, we can resolve this 5, 8 pair to 5, 8. Cleaning up here in row number 9, there's only one space for another candidate, and the only remaining candidate is 7. And that places an 8, 9 pair here in row 8, box 8. Moving up the right stack into box 6, let's take a look at this 15 cage. A 15 cage has only 2 possible combinations, and these are limited further by an 8 in column 9 and a 9 in column 8. Leaving only one order for each combination, setting a 6-8, 7-9. The next cage up the stack is a 13 cage, a 3-cell 13 cage, and the only remaining place for a 1 in box 3. With a 1 and a 1 here, there can be no 1 here. There must be a 1 here. That makes this a 7-9 to match the pair here. And with a 1 here, this is a 12 sum. And the partners of 7 and 9 in a 12 sum are 3 and 5. Now, both of these cage candidates can be resolved by answering the question, where can a 6 go in box 6? We have a 6 here. We have a 2-6 pair here. We cannot have a 6 in column 9 or a 6 in column 7. It must be here in column 8. And the only 6 in column 8 is here in this 15 cage. So the 15 cage must be a 6-9 pair. That resolves this pair to a 5-7. Let's try that again. 5-7. So that sums to 13. This sums to 15. And that helps us here in box 3, column 7. Where can we place a 9 and a 4? We've got 9s and 4s in columns 8 and 9. So the 9 and the 4 must go here in these 3 cells of box 3. Now, if there's going to be a 4 or a 9 in this 13 cage, we know that the only possible combination is the 4-9 combination. So since we have a 4 and a 9 into 3 cells, one of those has to be in the 13. So we can place a 4-9 pair here, and this 9 helps us resolve that to a 9-4 order of the 4-9 pair. Now, we know all of these candidates, so what are the remaining candidates in column 8? The remaining candidates in column 8 are 3, 7, and 8. This 8 means we can remove an 8 as a candidate there in row 3. And we know all of the candidates except for 1, and the only one that we're missing is a 5. So this must be a 5. Now this 4 helps us resolve this 4-5 pair to a 4-5. With that, we're as clean as we can get. There are no more pairs or triples that can be resolved. So let's move down here to column 7 in box 6 and fill in these remaining candidates, 2, 3, and 8. We can remove the 8 from this 2-cell 7 cage. And that's all the cleaning we can do. However, we can fill in the partners of the candidates of these cages. So the partners here are 5 and 4, but we can't place a 5 here because of this 5 in the row. So the only possibility here is 4, and its partner is 3. We can remove the 3 from the column, and we have a 2-8 pair here. The partners for a 2-cell 11 cage to 2 and 8 are 9 and 3, and it doesn't look like we can resolve those. So I think, other than this 7 and 9 that can help us clean that up a bit, I don't think we have any other cleanup that we can do. Now, we were in these 2 columns here. Let's move up into this top band into row 3 and work on this 2 cage a bit. I think this is quite limited. We know this must be less, this cage must be less than 13. We do have quite a few known digits in the row and column of this cell. It can't be a 1, a 2, it could be a 3. 3, 5 is less than 13. We can't have a 4. We can't have a 5 because there's already a 5. We cannot have a 6. We could have a 7. That's possible because it needs to be less than 13. We can't have an 8, but that would also make it 13, and we can't have a 9 because that would make this into a 14, which is not less than 13. So the 2 possible candidates for this 2-cell cage are 3 and 7, making it an 8 sum or a 12 sum. But that is quite nice because we do have another 3, 7 in that row, and that becomes a pair. So that limits down what we can have here in row 3. Moving on to crux number 3. Let's use the equals inequality clue here in column 3 between boxes 1 and 4. This clue can help us determine the value in both of these cages. But first we must determine the remaining candidates in boxes 1 and 4. And let's start up here in box 1. What are the remaining candidates here in box 1? Well, it looks like 1, 3, 6, and 7. Now, here in column 2, we have a 7, 6 pair pointing up here into row 1, column 2. So we can limit down the possible candidates by removing a 6 and a 7. And we also have a 1, 3, 7 here in row 3, which helps us out quite a bit. It gives us a placed 6, so we can remove the 1, 3, 7 from this cell, and we can also remove the 6s from that cell. Now, here in box 1, row 1, column 2, this must be a 1 or a 3, and it's in the same column as these 3 cells. So if this is a 1, there must be a 3 here. If this is a 3, there must be a 1 here. So we can place a 1, 3 as either or candidates, and the remaining candidates that are certain for this column in box 4 are 2 and 4. Same story here. We know there is a 7 here, and we know that the 1 and the 3 are either or. If this is a 3, then this will be a 1, 7 pair. If this is a 1, this will be a 3, 7 pair. So we can place an either or 1, 3 in column 3 of box 4, and the certain candidates are 5 and 8. Now, if we know for certain 5 and 8, that's a 13 sum. So 13 plus either 1 or 3. So if it was 1, that would be a sum of 14. If it was a 3, that would be a sum of 16. So the question is, for this 3-cell cage that spans boxes 1 and 2, can we use the known value of 6 and these possible candidates to add up to both 14 and 16, or are we able to eliminate one of those possible sums? So if we have a 6 here, let's start with 16. These would need to add up to 10. If we used the 1 here, this would need to be a 9, but we have a 9 here already in the row. So we know that if this was a 16, it could not be 1, 9. It would need to be 3, 7, and 3, 7. However, there's a 3, 7 here. So we cannot use the 1 here, nor can we use the 3 and the 7 to make 10 out of these two cells. So 16 is not a possible value for this 3-cell cage. And because it's equal, it's not a possible value for these 3 cells either. That means we must use the 1 here. This must be 14. 1 plus 5, 8. So we can remove the 3 here, which unwinds this. These are not 1s because there is a 1 here. This is a 3, 7 pair. That makes this a 1. And because of the 1 here and the 1 here, we can remove the 1 from this. So now we know this is a 2, 3, 4 triple. This is a 1, 5, 8 triple. We don't know exactly what these are yet, but let's work on that. We know this is a 14 cage. This must sum to 8. 8 and 6 make 14. So the partners of 3 and 7 to sum to 8 are 1 and 5. 7 and 1, 3 and 5. However, there's a 5 here in the row. So this cell cannot contain a 5, and the partner must be the 7. That resolves this pair to a 3, 7 pair. The remainder of this puzzle is only basic Sudoku and Killer Sudoku logic, so I've sped it up to 4 times normal speed. But stick around while I give my thoughts on this puzzle and its potential to be a difficulty 10 puzzle. Drumroll, probably not. Even though it has a low solving percent and a longer average solve time, I doubt it is a 10. Is it a 2? Definitely not. Even past the first big crux, there were still a couple of difficult spots that could challenge solvers. I think that it falls somewhere in between, maybe a 7. It makes sense to me that it has been inflated in its low percent solve and longer average solve time because it was given a 2 difficulty to start with. More or less experienced solvers tried this puzzle and had a difficult time with it, inflating the numbers. I was one of those. Either way, it is an enjoyable puzzle, and I hope more solvers try or revisit Puzzle 1765, and in so doing, balance out the statistics so we can get a better feel for its true difficulty. There we go with Puzzle 1765. I hope you enjoyed it as much as I did. If you are still here, please show your appreciation by leaving a positive or constructive comment, liking this video, and subscribing to the Killer Fun channel. Thanks for giving some love. We'll see you in the next video.